In this video, we're going to look at the product and quotient theorem for polar form of these complex numbers. The product theorem says that if you've got the product of two polar forms, that it's equal to the product of the radius of both times CIS of the sum of the two angles. So R1 CIS angle A times R2 CIS angle B is equal to R1 times R2 CIS of A plus B. So let's practice that product theorem. We have the square root of 3 CIS 45 degrees times the square root of 3 CIS 225 degrees. So for this example, I'm going to just write out all the given values. R1 is going to be the square root of 3 and angle A is going to be 45 degrees. R2 is also the square root of 3 and angle B is equal to 225. So now we can plug those into that formula. This product is going to be R1 times R2, or the square root of 3 times the square root of 3, CIS, and then the sum of those two angles, 45 plus 225. We can simplify this. This is the square root of 3 times the square root of 3 is 3. CIS and 45 plus 25 is 270 degrees. This is 3 times cosine of 270 degrees plus I sine of 270 degrees. Where I'm going with this is I didn't read that initial directions. We do want to multiply and then write it in rectangular form, that A plus BI form. So I need to take that polar form and now convert it to rectangular form. 270 degrees, that's our quadrantal angle, that negative y-axis, that ordered pair being 0, -1. So this is 3 times cosine of 270 degrees is 0, plus I times sine of 270 degrees is -1. Distributing that 3 times 0 is 0, minus 3 times -1 times I, or I added the minus there to change the sign. So this is going to be minus 3I. Two cosine 60 degrees plus I sine 60 degrees times 4 cosine 150 degrees plus I sine of 150 degrees. So we're going to take the product of our two radii, 2 times 4. And then we're going to add the two angles, 60 plus 150. So this in our polar form is 8 CIS 210 degrees. Or 8 times cosine 210 degrees plus I sine 210 degrees. $210 is going to be in our third quadrant. And that makes our reference angle going to be 30 degrees because we're going to take 210 minus 180. Since our reference angle is 30 degrees, that horizontal leg is going to be the square root of 3 over 2. Since we're in the third quadrant, that makes it negative. And the vertical leg is going to be 1/2. And again, since we're in the third quadrant, that's also going to be negative. 8 times cosine of 210 degrees. Cosine of 210 degrees is negative square root of 3 over 2. Plus I times sine of 210 degrees, which is negative 1/2. Distributing that 8, we're going to get -4 square root of 3 minus 4I. The quotient theorem is very similar to the product theorem. If we're dividing two polar forms, we're going to take the quotient of the radii, CIS, and then we're going to subtract those two angles, A minus B. So R1 CIS A divided by R2 CIS B is equal to R1 divided by R2 CIS A minus B. So we're going to divide and write in rectangular form. Again, I'm going to just identify the values from my two polar forms before substituting in. R1 is 3. A is 305 degrees. R2 is 9. And angle B is 65 degrees. So when I divide these two polar forms, I'm going to take the quotient of R1 and R2, so 3 over 9. CIS, and I'm going to subtract A minus B, 305 minus 65. 3 over 9 simplifies to 1/3. This is going to be cosine of 240 degrees minus plus I sine of 240 degrees. $240 is also going to be in that third quadrant, making our reference angle 240 minus 180 or 60 degrees. So our ordered pair for 240 degrees is going to be -1/2, negative square root of 3 over 2. Cosine of 240 degrees is -1/2. Sine of 240 degrees is negative square root of 3 over 2. And now I'm going to distribute the 1/3. 1/3 times -1/2 is -1/6. 1/3 times I times square root of 3 over 2 becomes negative square root of 3 over 6I. And our last example just has us rationalizing the denominator. A quick review. When we're rationalizing the denominator, our goal is to make it so that the denominator is a rational number. Square root of 5 is not a rational number. Neither is I. I is imaginary, so it doesn't even fall under the real number system. So we want to rewrite this expression 8 divided by the square root of 5 minus I in such a way where the denominator is this nice rational number. We've seen rationalizing the denominator in many examples where we just had one square root or one radical in the denominator, and we multiplied by that radical over itself. Very straightforward. But when we have a binomial, so two terms, we want to multiply by the conjugate. This is also true if we've got radicals and or imaginary numbers. But that binomial, we want to make sure that we multiply by the conjugate of the denominator. So we're going to take 8 divided by the square root of 5 minus I, and we're going to multiply it by the square root of 5 plus I over the square root of 5 plus I. Again, multiplying by this expression, this fraction, is the same as multiplying by 1, so we're not changing that. Adding some extra parentheses to help me see that. The numerator, I'm just going to distribute the 8, so we have 8 square root of 5 plus 8I. And in the denominator, I need a FOIL. So the square root of 5 times the square root of 5, this is the square root of 25. The square root of 5 times I. And then negative I times square root of 5 is negative I square root of 5. And I'll write this second term. When I'm multiplying the square root of 5 times I, that's the same as I times square root of 5, so keeping that I out front. And then negative I times positive I is minus I squared. The square root of 25 is 5. And these middle terms, I squared of 5 minus I squared of 5, sum to 0, so they go away. And then we're subtracting I squared. We need to remember that I squared equals -1. So this is minus -1 in the denominator. That's the same as 5 plus 1 or 6. Now we still have some simplifying to do. All of these terms have a factor of 2. So 2 times 4 square root of 5 plus 4i divided by 2 times 3. That like factor of 2 in the numerator and denominator simplified to 1. So we have 4 square root of 5 plus 4i divided by 3. Now, in terms of syntax, how we write this is going to be read perfectly fine by most humans. But in terms of technology, a lot of times we do want, programs do want the real and the imaginary part separate terms. So they might require that this is written 4 square root of 5 over 3 plus 4/3 I.